All right, this is Coach Williams, and we are going to go over the notes for 7.2 and 7.3. We've been talking about polynomials, and in certain cases here we've got some binomials because they have two-term expressions here. Binomial here, again, because there's two terms. And we're going to talk about multiplying two binomials today in 7.2. And then we'll learn some special situations or cases where we're multiplying the same binomial times itself, or the difference of squares, where we multiply a binomial that adds the constant and then subtracts the constant. So that'll be in 7.3. But the first thing we're going to notice here, these are steps that you can use to multiply binomials, and this is often referred to as the FOIL method. And the reason it's named the FOIL method, if you'll notice the first letter in each one of these steps spells out the word FOIL. FOIL or FOIL, depending on where you're from in the country and how you're raised, kind of like envelope and envelope, potato, potato, tomato, tomato, potato, potato, tomato, tomato. It's Metrocity or Metro City, I'm not sure which, but anyway, this is the FOIL method, and it just refers to the first letter in each one of these steps. And the first step would be that you multiply the first terms times each other. So we're going to take the first term in this binomial, first term in this binomial, and we multiply that together. We end up x times x, which gives us this x squared. Then we're going to talk about multiplying the outer terms. And the outer terms here are going to be the outermost terms. So we've got this x term here and the 2 term in the second expression. So we're going to have 2 times x, or x times 2, which gives us 2x. And then we multiply the inner terms, or the inside terms, which is going to be our positive 1. I need to make sure we're circling the sign with that, because positive 1 times x, so it's just 1x or x. And then the last thing we do is we multiply the last terms in each binomial. So we're going to multiply the positive 1 times the positive 2. So positive 1 times positive 2 is going to give us a 2. And then we simply add all of these together. We add all of these terms that we've multiplied together. We get x squared plus 2x plus x plus 2. And if you'll notice, these middle terms will combine because they're both x terms, x to the first power terms. And so we end up with this 3x when we add 2x plus x. So our final expression in standard form is going to be x squared plus 3x plus 2. Now that's the FOIL method, and right now we're dealing with x to the first power. But if we ended up with some terms that might be to higher powers than 1, just remember that when we multiply variables, we want to add exponents. Okay, and we'll see this on a couple of these that we run into in our practices and in our examples as well. But we want to add exponents, meaning that if we had an x to the first times x to the first, that's going to be what? We add these exponents together, that's x squared. Okay. If we had x times x squared, or x to the first times x squared, we add 1 plus 2, and we get x to the what? Third? Exactly, third. All right, and then if we have x squared times x to the cubed, or x to the third power, x cubed, we end up with x to the what power? X to the 2, yes, to the 5th power, x to the 5th power to the 2 plus 3, which would be x to the 5th power. So when we're multiplying exponents, just remember that rule there, that we're adding those exponents there. Multiplying the variables, we add exponents. And that will save us from getting in trouble with the wrong exponents on our variables when we multiply. Another way you could look at this multiplication process, you could use a table, or kind of a little table or box method here, and you could put your terms in a table just like you would see in a multiplication table, where you have 0 to 0 to 10 going down this side, 0 to 10 going this way, and you just multiply each term across wherever they intersect. We can do the same thing with binomials. So we could have x and negative 3. Okay, so we have our x and our negative 3 that we put on this side. On this other side, I'm going to have x and negative 2. Okay, and so this is another way to do the multiplication of the binomials. And where these intersect, we're just multiplying those together. So we're going to have x times x, which is going to give us what? X squared. Okay, so x times x is x squared. X times a negative 2, so where these two intersect, I'm multiplying the x times a negative 2, which gives me a negative 2x. Where these intersect here, negative 3 and x, I'm multiplying those, so I have a negative 3x. And then where the negative 3 and negative 2 intersect at the table, I'm going to multiply them. I have a positive 6. Okay, positive 6. And so if I look at this now, I could actually combine these x to the 1 or x to the first power terms when I rewrite this in standard form. And remembering what standard form does, it goes from the greatest exponent to the least exponent. What's my first term going to be here if I'm adding all the things inside here together? What's going to be my first term? x2 or x squared? Yes, x squared. Then I'm going to add these two together for that middle term. So it's going to be a negative 5x. Very good. And then the constant on the end. So we're going to have a plus 6. And so there is your answer to the product there of those two binomials, and that's written in standard form. X squared minus 5x plus 6. Okay, we can do the same thing on 8 and 9 using this table. You can, put in your y, which is your first term. Your second term we can put in right there. And then we can put in our y here, and then our second term is a negative 6. Okay, I'm going to change colors here for the things that we're going to put in to the final expression here. Y times y is going to be a y squared. Y times negative 6 is negative 6y. 1 times y is going to be y, and 1 times the negative 6 is going to be negative 6. Again, I can combine those terms there because they both are y to the first power. So they're common terms there. So they're like terms. We can call it like terms. And so my answer here is going to be in standard form. What's going to be the first term? Y squared. And then I'm going to add these two together. So I have a negative 6y and a positive y. So I end up with a negative 5y. And then the final term is going to be this constant of a negative 6. And that is written in standard form. And the answer to number 8. On number 9, just to give you a little more to think about in terms of this multiplication process, all we're really doing is distribution. In fact, let's write that down. Distribution. That's all we're really doing with this process. If you'll notice up here, let's look back at our FOIL method. All I'm doing is taking the first term, multiplying it times the first term in the other expression. And I'm taking the first term, multiplying it times the last term in that second expression. Okay? And then I'm taking the second term in that first expression times the first term in the next one, and the second term times the last term in that expression. So all I'm doing is just distributing each term into the following expression in the other set of parentheses. I am taking each term and distributing it into that next parentheses or next expression. So that's all it really is. It's just distribution. And if we look at that, we could say, okay, well, I'm going to take Q, I'm going to multiply it times Q, and then I'm going to multiply it times 7. Okay? And then I'm going to take this positive 3, and I'm going to multiply it times Q, and I'm going to multiply it times a positive 7. Okay? So if I did that without using the table or without using, the FOIL method per se, I'm just distributing this, these parts. I've got q times q, which is q squared. Then q times 7, which is going to be a positive 7q. Then I've got 3 times the q. This is the second part. So I've got 3 times q, which is going to be positive 3q. And then I have 3 times 7, which is positive 21. Right, so separating it into my two different terms I just distributed this q into the second expression here, and the positive 3 into that expression here. And then I can combine these two terms in the middle. And when I get my final answer, I will have q squared plus 10q plus 21. Okay? So it's just distribution is all it is. If you can understand that part, you don't have to worry about building the tables or trying to remember the term FOIL. If you just know that you've got to distribute this, then you're going to be in good shape. Now we can go ahead and put the table in just to confirm that what we did was correct. And you know that we're going to have a q here and a 3 and a q and a 7. And so we'll have q squared, we'll have 3q, we'll have 7q, and we'll have 21. And again, we're going to combine those middle terms. So we'll have our q squared here, we'll have 10q, and we'll have 21. So we end up with the same thing. Okay, so whichever way helps you remember the best to get these products of binomials. And in a minute we may end up we're going to run into a trinomial too. But whatever helps you best to see this, if you can just remember, bottom line, we're just distributing the term into the parentheses, then that's good enough. Okay, let's look at 4 through 9. If you look at 4 through 9 here, we're going to multiply a couple binomials. Here we're going to run into some higher power or higher exponents that are greater exponents. And then we're going to run into some trinomials times binomials as well. And I'll show you that we can still do those the same way. Okay, so on this first one, on number 4, let's distribute just taking the x times the x and the x times the negative 1. And we're going to get x squared and negative x. And then if I do the second part where I take this negative 2 and I distribute it into the other side, the other expression or binomial, then I'm going to end up with a negative 2x and a positive 2 when I multiply negative 2 times negative 1. Okay, so that should be my expression, but I need to combine like terms here, which is going to be this negative x and negative 2x. And so my final answer will give me an x squared minus 3x plus 2 in standard form. Again, we could have built the table. We could have actually called this the FOIL method because we did the first term, then we did the outside terms or outer terms, then we did the inner terms, and then we did the last terms. But we just know it by distribution, and that's what we did. And so we got the answer. All right, and that is in standard form there for number 4. Number 5, b minus 3 times b plus 2. Do you want to do this by distribution, FOIL method, or table? Table. Let's try table one more time. So if I drew a table here, I'm going to have 2 terms here. I'm going to have 2 terms here. And then we'll multiply those across. I'm going to have a b and a negative 3. And for the second one, I'm going to have b and a positive 2. Okay. When I multiply those together, I'm going to end up with a b squared. B times 2 is going to give me a 2b. Negative 3 times b is going to give me a negative 3b. And negative 3 times 2 is going to give me a negative 6. So now, once again, I can combine these terms here that are b to the first power. And so my final answer is going to be b squared minus b, negative 3b and a positive 2b is still going to give me a negative 1b. And then I have negative 6 for the constant that's left on the end. And that's written in standard form. Greatest exponent to least. We're going squared, first power, 0 power, basically. Okay, on number 6, let's FOIL this one, or distribute this one. So we're going to start with this 4n squared, and we're going to multiply that times 3n squared. Okay, what is 3n squared times 4n squared? Well, 3 times 4 is going to be 12. And then we got n squared times n squared, which means we add the exponents together, so it's n to the 4th power. All right, and then we're going to multiply the 4n squared times the positive 4. Okay, so 4n squared times positive 4 is going to give us positive 16n squared, yes. All right, moving on to the negative 1. Now we're going to take negative 1 times the 3n squared and negative 1 times the 4. Well, the negative 1 just changes the sign of each term to negative. They remain the same term, just with a sign change. So positive 3n squared becomes a negative 3n squared. Positive 4 becomes a negative 4. Now you'll notice, once again, I can combine terms in the middle here, this 16n squared and the negative 3n. So my final answer in standard form, greatest degree to least degree here, is going to be 12n to the 4th plus 13n squared minus the constant negative 4 there, or minus 4. Minus the constant 4. Okay, on number 7, I'm going to do number 7 and 8. We'll do one by distribution and one using the table, because I want to show you the table still works in this case. But let's do number 7 like we just did number 6 using the full method. So if or the distribution method, we'll say, we're going to have 1, or this first term, we're going to multiply this x times the x squared, multiply it times the x, and we're going to multiply it times the negative 1. Now, I always like to do this here because I'm multiplying it times a positive x squared, positive x, and a negative 1. So we keep our signs straight as we move along. We're going to have x times x squared. What's that going to give us? X to the 3rd power, right? We got x to the 1st times x to the 2nd. We add those together, we got x to the 3rd. Then we're going to have x times x. Well, that's just going to be x squared. Then we're going to have x times negative 1. That's going to give us a negative x. Okay, when we go to the second term in our binomial, we're going to have to multiply it times all 3 terms in the trinomial expression. And so we'll have negative 2 times x squared, which gives us a negative 2x squared. Then we'll have negative 2 times x, which will give us a negative 2x. Negative 2 times negative 1, which gives us a positive 2. Okay, now here we're going to see we've got a positive x squared term and a negative 2x, and we can put those together. We also have a negative x and a negative 2x, and we can put those together to simplify this expression to what we need. So we're going to start with the x cubed because it has the highest degree. X cubed. If I move to the x squared, I've got a positive x squared, negative 2x squared, so it's going to give me a negative x squared. I've got negative x and negative 2x. That gives me a negative 3x. And then I've got the constant of positive 2. So my final answer should be x cubed minus x squared minus 3x plus 2. Okay, as mentioned, let's do this one in the form of a table so that you know that you can still make the table work even though you're multiplying a binomial times a trinomial. So if I go 2 on this side, but I'm going to go 3 on this one. So I'm going to have 1, 2, 3. Okay, so I've got 2 on this side and 3. I've got some kids that are complaining because they drew their boxes wrong. So I've got 2 here and then 3 terms here, right? So let's fill those in now. I'm going to have 2 and a negative a. They also kind of reverse the order here, but that doesn't matter. It doesn't matter what order they're in. We just multiply them together and we put them in order when we finish up. This is going to be a 3a squared. Then we'll have a positive 3a. Then we'll have a negative 5. So we have our binomial here and our trinomial here. And this is still going to work out just fine. We can multiply this and put it, simplify everything, combine like terms at the end, and it's going to work out just fine. So we're going to have 2 times this 3a squared. Well, 2 times 3a squared is going to give me 6a squared. 2 times the 3a is going to give me 6a, and 2 times the negative 5 is going to be a negative 10. All right, and then we'll move to the next term. We've got a negative a times 3a squared is going to give me a negative 3a cubed, because we have a to the first power, a squared, so this is going to be a to the third power. All right, and then we're going to go to the next one, which is negative a times 3a, so it'll be a negative 3a squared. And then the last thing we have is negative a times negative 5. It's going to give me a positive 5a. Now this one changes order a little bit because we changed the order of our terms here in the front, but if you'll notice, we can still combine our a terms here, and we can still combine our a squared terms right there. The highest degree term that we have here, or monomial that we have here, is going to be 3a cubed. So this negative 3a cubed is going to be the first term, and that takes care of this one. The next one is going to be a squared, and a squared, we have a 6a squared and a negative 3a squared. So we combine those, we're going to have a positive 3a squared. Then the a to the first power, or just simply a term, comes next, and I have 6a plus 5a, which is going to give me a positive 11a. And then our constant is on the end, negative 10. So it still works with a trinomial just like it would with a binomial. Just have to create an extra column for that term. And the products, as it is multiplied times the binomial. All right. On number 9, I'll draw this table a little differently as well, just to show you that you could have the trinomial on the left and the binomial on top. It doesn't really matter. So I could have my 3 terms here, and I could have my 2 terms here, and I can still come out with the same thing. It doesn't matter the order or the direction in which you start here as far as putting the trinomial on top or the binomial on the top. It doesn't really matter. So I will start here with my 2p squared, and then I'll have a p, and then I have a negative 3. Across the top I'll have 3p and a negative 1. Okay, so now when I multiply 2p squared times 3p, I will get 6p cubed. And then when I multiply 2p squared times negative 1, I'll get a negative 2p squared. P times 3p, 3p squared. P times negative 1, negative p. Negative 3 times 3p, negative 9p. And negative 3 times negative 1 is a positive 3. If you'll notice here too, again, it's the order changes a little bit here of what terms combine, but my square terms are going to combine here, and then my p to the first terms will combine right there. Okay, so final answer. We're going to have 6p cubed. That's the highest degree term that we have. I'll combine 3p squared and negative 2p squared, and I'll end up with a 1, or a positive 1p squared. Then I'm going to have this negative 9 and negative 1, which makes a negative 10p, and then I have my constant of 3, and that's my answer on number 9. Alright, and that kind of wraps up just basic, multiplication of binomials and trinomials. Then 7.3, if you flip the page, 7.3 is going to deal with some special cases. And this is going to be the square of a binomial, where you're going to have the same, first and second terms here times each other. So in this case, they show you an a plus b, and they're going to square that. And then they're going to have this example we're using a number, so you have x plus 5, and you're squaring that. If you noticed in our first section there, or 7.2 section, when we multiplied, we had common terms that combined in the middle. So we might have two x terms, x to the first degree terms that combined in the middle, or you might have had two x squared terms that combined. And so you're going to start to notice a pattern, and it's not important that you see this right away. As you do more of these, you'll begin to catch on and see this. So don't panic if the pattern thing gets you and it's just too much to soak up right away. But if you'll notice here, the way a pattern is going to work for multiplying binomial times itself, you're going to square the first term, and that will be your first term in your answer. You're going to multiply the first and last terms times each other and double it, and that will be your middle term, and then you're going to square the last term, and that will be your last term in your final answer. So if you'll notice that is in this example of x plus 5, they squared the first term, which gives us x squared. They took x times 5, and they got 5x, and they doubled that, because you're going to end up with two of those anyway. They doubled that to get the middle term. And then they take the last term, they square it, and that gives you your last term. So x squared plus 10x plus 25 is the answer for that one. And you're going to see this happen quite often with perfect squares, we'll say, or binomial squares. You can do the same thing when you have a negative or positive, it doesn't matter. When you take a times a negative b, you'll get negative ab. Double that, so you get negative 2ab. Still squaring the first term and squaring the last term. And then they give you an example here using some real numbers. Okay, the next part is when you have the difference of squares. In other words, you've got a plus some number, and then b, or a minus b, or some number b. So you have a plus b, a minus b. It's the same terms, it's just one's plus, one's minus. Basically, the middle terms will cancel each other out, and I'll show you how this works. Kind of, if you think about it, you're going to multiply your inner terms times each other, and you're going to multiply your outer terms times each other. And on this inner term, you're going to have a positive AB. On the outer term, you're going to have a negative AB. So when you combine those terms together, they will cancel each other out, leaving you with just the square of the first term and the square of the last term with a minus sign in between. Okay, so that's kind of an example here, x plus 3, x minus 3. It's just going to be x squared minus 3 squared, which is 9. So there's your examples of some of the patterns that you're going to see with squares and then difference of squares. Let's look at a couple of the examples on the extra practice, and this will go pretty quickly as well. So in this first one, if we just broke this apart and we said, okay, a plus 3 times a plus 3, again, you're going to see this happening where we're just going to end up with the square of the first term, a times 3 doubled for the middle term, and then 3 squared, or the last term squared, for the last term in our answer. But distributing this, you can see it as well. we'll end up with a times a times 3. So we're going to have a squared, a times 3 will be 3a. And then we're going to go 3 times a and 3 times 3. So we'll have again another 3a, and then 3 times 3 will be 9. So, like we mentioned, you're going to end up with 2 of the same terms in the middle. That's why in this pattern you can just take the first and last term, multiply them, double it, and you'll end up with this answer with the first term squared, this times 2, which will be plus 6a, and then the square of the last term, which is 9. Again, this is just kind of noticing the patterns. This is a squared plus 6a plus 9 is what the answer is going to be there. Okay, and again, this one being squared times itself, we can just take the first term and square it. We can multiply these two together, which gives us, let's do it this way. We're going to have a negative 2 times b, and then we're going to double that, and then we're going to have this negative 2 times itself, which will be a positive 4. Okay, remember the pattern says we're going to multiply these two and double it for the middle term, so negative 2 times b, then we're going to double it, so we'll have b squared minus 4b plus 4. Now again, if you didn't know this pattern, you can still use the distribution method, you can still use the table, and multiply this out, and you're in good shape. It's not a big deal that you see the pattern right away. We're just trying to help you kind of know that it's there so that you can look for it as you move along. On the last one, we would square the first term. So the first term squared, negative 2x times negative 2x, would give you a positive 4x squared. And then we're going to multiply this times this. We're going to take this term, multiply them together, and then double it. So we're going to say 2 times that, right? So we're going to have negative 2x times 1, which is just negative 2x. We double that, we get a negative 4x. And then we're going to take the last term and square it. 1 times 1 is simply 1. So in standard form, there's your answer for number 3, 4x squared minus 4x plus 1. Okay, on to number 4. On number 4, we have a difference of squares. And we'll work this one out like we did before. If we take x times x and x times 3, we have x squared, and then we'll have a positive 3x. On the second part, if we take this negative 3 times x and negative 3 times the positive 3, we're going to end up with a negative 3x, and then we have negative 3 times positive 3, which is a negative 9. Again, because this is a difference of squares, one's negative, one's positive, our middle terms will cancel each other out. And since they cancel each other out, we end up with x squared minus 9. Or if you think about this again, we'll have the first term squared minus the last term squared, and that's it. The middle terms cancel. So number 5, remembering that rule, what's this one going to be? Q squared minus the square of the last one, which is 5 squared, so we'll have 25. And then for the very last one, number 6, a difference of squares. One's plus, one's minus. Minus first, plus second. We multiply the first one times itself, so we square the first term. T squared. If we multiplied this out, we'd end up with a negative 11t and a positive 11t. They just cancel, so we just wipe out the middle term. And the last term is negative 11 times positive 11. Yes, minus 121. And that's the answer for number 6. All right, that concludes the notes for 7.2 and 7.3. multiplying binomials and then some binomials times trinomials. You can use the distribution method. You can use FOIL method, which is distribution. You could also use the table method if that helps you out. And then just recognizing some of these rules can probably help you solve these products rather quickly, knowing that you don't have to actually multiply some of these out because they're going to cancel out for middle terms, or they'll double in the case where you're multiplying perfect squares. So, all right, guys, have a good day. We will see you guys in class tomorrow.